Hi everyone. Thanks for coming for my talk. And I'm going to be presenting on Kubernetes admission controllers. So we are going to be talking about what's Kubernetes and what are the primary components of Kubernetes, and also what's the architecture of Kubernetes and so on for people to get a basic understanding of Kubernetes. And then we're going to be talking about admission controllers, which are like a type of objects in Kubernetes, which people can leverage, blue teams can leverage to build secure Kubernetes clusters. Basically, they can block security misconfigurations, like any default security misconfigurations and so on, by using admission controllers throughout the cluster. I'm Nishaanth. I work as security consultant with MDSec, and I've been doing application security for the last couple of years. So the agenda for the talk is basically go about Kubernetes, see some of the core principles of Kubernetes, the architecture, how do you set up a Kubernetes cluster locally, and also in the end, we're just going to see how do you go about creating a cluster, like a production-ready cluster, just for the purpose of testing or security research and so on. And also we're going to be saying about common misconfigurations, 3 or 4 common misconfigurations, and what's admission controller, and also how to write admission controller using any programming language, be it Go, Python, Java, or something else. So basically Kubernetes, which means navigator in Greek, it basically means navigator, and also it has been developed by Google some 10-15 years back, and the previous project name for Kubernetes was Project Bog, and also some of the principles and the names which come in Kubernetes are heavily taken from this TV show Star Trek, and also since Kubernetes was open sourced a couple of years back, Google had been already using Kubernetes long back internally, and it had multiple iterations of the same tool. And the last stable product is Kubernetes, which was released in a couple of years back. So we might have this question that right now already people are using monolithic architecture, the architecture which has been followed for the last couple of years. A lot of companies are already using it. Why would you need Kubernetes? What's a factor that's differentiating the current scenario of applications? What's the benefit of Kubernetes? Is that for huge enterprises which have multiple web applications which are running multiple databases, it's really easy to configure or run multiple clusters, multiple pods, right, with Kubernetes. And Kubernetes being a very stable tool, it automatically handles all the incoming traffic, it handles the proxying of IPs to nodes, and so on and so forth. And one of the main architecture principles of Kubernetes is decide state principle. So basically, decide state principle is just a configuration or something that says that at any point of time when the Kubernetes cluster is running, I want 5 Nginx servers to be running. You just say Kubernetes that I want 5 Nginx servers to be running almost all the time, and say a pod crashes, 1 or 2 Nginx servers crashes, Kubernetes is going to automatically pick that up, saying that, okay, those 2 pods crashed, those 2 Nginx servers crashed, and I'm going to take care of that and again, rebuild the whole pod and bring up the whole pod by itself. So this is basically decide state principle, and it basically checks for, so when we build a cluster or build a specific pod or a specific service or so on, you can just say that this is my decide state in terms of replicas, or you can configure it in the parameters. You can just say that I need 5 clusters, and it will bring up not 5 clusters, 5 pods, it will always make sure that the pods are running. So this is one example of configuration. Here we can see the replicas is set to 4. So basically that means that the image Nginx is going to be running on the cluster on 4 different pods at all times. And whenever it crashes, the kube controller or the kube controlling manager is automatically going to pick it up, and the scheduler is going to assign a note saying that, okay, this pod crashed, I want, just bring it up again, and so on and so forth. And all of this, since it does it automatically, like I would say intelligently as well, because of the forwarding logic, which it does, and also if there are like, say, 10 different nodes, like Kubernetes already knows where to put your pod on based on what's the CPU usage of all the nodes. Say, for example, one node is like not used at all, like it's not used at all in terms of CPU, and it's free. Kubernetes is going to pick that up saying that, yeah, that node's pretty free, I'm going to put my pod on there. So it can get a bit confusing with a lot of new terminologies, new components in Kubernetes. Like I've just tried to map, like for example, take a web application. I've just tried to map all the web application components to Kubernetes components to just to make it understand better. So the first, let's just say that we are using a web application which was written in like whatever language, and is using monolithic architecture. Like basically the whole of the web application, the databases, and pretty much everything related to the web application, like all of them are run in a single component. And say for example the DB server goes down, the entire web application goes down as well. So since with Kubernetes you can create like multiple pods, multiple containers, what we could do is like we can create, so the first thing which we are going to see is basically pods and containers. So containers are nothing but like Docker containers. Kubernetes has support for multiple different runtimes, and Docker being the predominantly used one, like a lot of people just go with Docker. So basically containers are nothing but components of your web application. Like say we have a web application which has a sign-up functionality and a payment functionality. You can decouple all these functionalities and run on specific pods. For example, run a sign-in functionality in a single pod, run the payment functionality in another pod, and say run forgot password or other sign-up functionalities on a different pod. So this way, even if the sign-in pod goes down, the entire web application doesn't go down. It's just the sign-in functionality is not working in the application properly, but still the whole of the web application is still going to work. So that's containers. And pod is basically a abstraction on top of containers. You can't run a container directly in a Kubernetes cluster, but you run a pod. So basically when you run a pod, in the backend what happens is it creates a container based on the image name you give or based on the configurations that you give, and it creates a pod. And the next one which we're going to see is sidecar. So basically sidecar is nothing but again like a type of container, but it has a different purpose too. Say for example we have a web application and there is a logging server, or there is a server which logs all the Apache logs or authentication logs and so on. What you could do is like you can run both the containers, like the web application container and also the metric server container in the same pod. So the second metric server container is called the sidecar because it's depending on the first container to be running, and it like takes an action on the first container and does whatever it wants to do. So that's sidecar. And namespaces are basically like, say, for example, there is a huge company and there are like multiple environments, right? Like there's UAT, pre-prod, prod, and so on. You can't put all of the resources in the same place. They have to be segregated properly. So that's why namespaces were written in Kubernetes. Namespaces are just like, like logical separation of the whole cluster. Like when you create a production namespace, all the resources which you deploy and you put on the production namespace, that's going to be isolated from the other namespaces, so that even if say for example a production namespace gets compromised, it doesn't affect the other namespaces. And Kubernetes handles the namespace isolation in terms of access of network, the network access, file system access by itself, and it's just a matter of creating a namespace and deploying all your resources in the namespace. So that's namespaces. And Node. So the Node is nothing but the computer where the server is running. So take a traditional web application. The Apache server is going to be running on a, say, Ubuntu server or a Windows server, right? So that's basically Node that's basically Node in Kubernetes. And Node can have like a port, which is a Node port, and Node can be a service. We'll see what's a service in a bit. So, okay, so consider like we have deployed a web application, right? Kubernetes has automatically created IPs, but all of the IPs are internal. You can't reach cluster IP or the service IP from outside the world, right? So how do people access websites which are run on Kubernetes from the outside? That's where service and ingress comes into place. So for example, say there are like 10 different containers running, right? And all the containers are talking to each other. And the thing with containers is when they die or when they crash, all the data which is stored in the container or whatever configurations which were there in the container also gets killed or gets deleted when it restarts. So that includes the IP as well. Say, for example, the sign-in container had a specific IP, and now that it crashed and it restarted, the IP is going to be different. And you can't like handle all the IP changes by yourself, right? That's why services were born. So service is nothing but a mapping of an internal IP, which is like in the range of 172 with a name called so basically payment is the service name and default is the namespace where the service is going to run, and SVC is just the service. So now that we have got assigned an IP of 172 whatever, you still can't reach it, right? Because it's an internal IP. So that's why we use ingress. So ingress is basically you forward the whole internal IP outside to the world. So say when we create an ingress, it creates a IP and maps it to a port in the backend. And when that happens, since it's an external IP, people can reach it from the outside world, and it comes to ingress first. And ingress is going to see which service it needs to translate it to or just send it to, and it's going to send it to that specific service. And deployments are nothing but say we have a, say in terms of a web application where it has a database, it has a web server, it has like multiple web servers, and it has like volumes and so on. When we write YAML files to, bring up the cluster, it's really inconvenient to write different, say for 10 different servers, you can't write 10 different YAML files, right? You can't write 10, for 100, you can't write 100. So that's why deployments were born. So basically when you configure a deployment, what happens is that inside the deployment, you can say that, all right, when I run a deployment, I want a specific server to be run, say Nginx. I want Apache to be run. I want this specific metric server to be run, whatever. And you create the deployment and you run the deployment. What happens in the backend is that all of the servers or all of the images which you have given to the deployment gets brought up by itself. So that's deployment. And volumes are basically database. Volume is a database component, and stateful set is again a database component. But with stateful sets, volumes can be used for storage, but not for components which I would say require real-time real-time synchronization. Say a database which has usernames and passwords. If it's not getting synced at real time, people are not going to be able to use the web application or the server, right? So that's why we use stateful sets. But for volumes, you can say store SSH logs. You can store reports, whatever, which doesn't really require real-time synchronization. That's volumes and stateful sets. And secret is basically the database username, database passwords, private keys, SSL keys, and so whatsoever, which you want Kubernetes to use. So you create a specific resource called secret, and you just say that, okay, this is my secret, save the secret. And when you write the YAML file to bring up a pod, it will automatically refer the secret from the cluster and do whatever it wants to do. So that's secret, and config maps are similar to secret, but config maps you can't, it's not recommended to store sensitive information in config maps, just like information of websites, port numbers, which are just information which are like not sensitive. So that was like the list of primary components in like most used resources in Kubernetes. And like when we run a Kubernetes cluster, there are like multiple components, and basically it's run as a master node and a slave worker node, and you can run as many master nodes you want, and also you can run as many worker nodes you want. So both the master and both the master and the worker nodes have different set of services or components which are running inside, and all of them are responsible for different shit, which we will see in the next slide. Yeah. So whenever a specific request comes to the Kubernetes cluster, it goes through the API server always. Like the whole of the authentication, authorization, whatever is gonna get deployed, all the authentication for the servers and everything, that goes to the Kubernetes API server first, which is basically exposed if in terms of the master node, so that the worker nodes can talk to the API server, tell what it needs to do. And the first thing it goes to the API server, it's going to check for authentication. It's going to check if you have given the right kubeconfig file, and the next thing it's going to go ahead and see if you have the specific authorization principle for Kubernetes. And yeah, like with the other components, like so basically in the worker node, there are two components which always run. One's the kubelet and one's the kube proxy. Kubelet is responsible for bringing. So basically, what happens in the worker nodes? Say we create a pod of Nginx. The master creates it, but it's being run on the worker nodes. So the master just like tells where to put it on, like what to do, and the worker nodes basically run those containers. So kubelet is responsible for bringing up containers, managing the containers in the worker node, talking to the main clusters API server, like getting information from the API server and so on. And kube proxy is another component which is used in the worker nodes. It's basically kube proxy just like handles all the IP translations or like resource translations. Like for example, where to put what, like just like see if that specific worker node has resources to run a specific pod and so on and so forth. So that's kubelet and kube proxy. And there are other components as well. And etc daemon is basically the database storage which Kubernetes uses. So all of pretty much everything in Kubernetes is stored in etc daemon. And etc daemon has a list of like what images are you running, what replicas you're running, how many pods you're running. Even the decide state principle which we saw earlier, the values for the replicas and the original state and the decide state, all of the values get stored in the etc daemon. Say you store secrets, that gets stored in the etc daemon. So etc daemon is just a database store, I would say. And scheduler, so basically scheduler is responsible for scheduling a specific resource. Like say that you want to run a pod, scheduler is going to say that, okay, I know where to run it. But with kube controller manager, so the controller manager, like scheduler just schedules it, but it doesn't know where to schedule it, right? So that's the responsibility of control manager. Controller manager is going to pick up if something is wrong. It's going to tell scheduler, okay, this is wrong. Schedule this pod on this specific node, and the scheduler is going to talk to the kubelet, go to the kubelet, and the kubelet is going to bring up the service or whatever. And setting up Kubernetes locally, like if we want to quickly set up like just hack around like real time. Like we can use this software which is given by Google called Minikube. It's not recommended for production though. It's just like for testing, or it's not it's not feasible to run a production cluster every time you test. Like say you want to test a specific deployment, you can't bring up the whole cluster and test it. Like that's why people use Minikube, and it's quite straightforward to use Minikube. You just like download the binaries for Minikube, add the groups for the specific user which you're gonna run, and just start up Minikube. It's gonna run a cluster by itself, and both the master and the worker node are going to be in the same node in Minikube. But that's not the case with production cluster, because if you can't basically run both the master and worker node on the same computer or the same node, because that's how the production clusters work. Like if the master goes down and like you wouldn't know what to do, or if the worker node goes down, the master still is up, and that's like, yeah, this is wrong. So that's with setting up of Minikube. And like, yeah, so like some of the most common misconfigurations, I would say, which we've seen in the engagements for Kubernetes, is the first thing being people usually, how we talked about namespaces. So what people do is, like developers do, is they deploy all the resources in the default namespace. So by default, Kubernetes has this namespace called default, and they recommend that people don't use it to push resources into default namespace, because the people can, if an attacker gets access to the cluster, they can basically get access to the service token of the default namespace and just abuse it, because since all the resources are there in the default namespace and there is no isolation in terms of network or file system, it's a bad practice running namespaces. And bad pods. So bad pods are basically like container, like that containers are just like yet another process in Linux, right? It's still a process which is running in the same node. So it would be possible to break out of the container runtime and escape to the host or escape to the place where the cluster is running if you can create a bad pod. By bad pod, I mean it's like a super privileged pod, and also if you could get root on the container, and if the container is configured to have privileged option, then it could go really bad, because it's quite trivial to escape to the host if it's a privileged container. So it's really recommended not to set your containers as privileged or use any capabilities which give you access to the root of the whole container system or the host operating system. So yeah, again, Linux has like this thing called capabilities. It has like lot of different capabilities, and when we assign a capability to a process, what it does is that say for example, let's take ping. Ping requires like network socket creation and send the socket to a different client and so on, right? That should require super user privileges, but when we run ping, we don't do sudo ping. We just do ping, right? That's because ping, the ping command, the ping tool has been given a capability to send raw TCP packets or UDP packets to different servers. Even though it's not root, it can still run like socket, run all the privileged socket API calls, just because it has the Linux capability to do so. So that's bad pods. And malicious images, like say for example, in a production environment, like people use Jenkins to deploy software, right? Like most of them use Jenkins. Say the Jenkins get compromised, what would happen? Like, would it be possible to load a random image, or like say you host a C2 on a different platform and try to pull it into the cluster? And also like by malicious images, like say an image which is outdated or which has a critical vulnerability and so on. So that's malicious images. And insecure RBAC. So RBAC is again like one of the main components of Kubernetes. Like per se, Kubernetes, you can't create users. Like, it's not like you can go to the cluster and say, I need a new user called Nishaanth. You can't create it. It's just how basically you create a system, you create a user on the node and you assign RBAC permissions of Kubernetes to that specific user. Say you say that, okay, this specific user can create pods, delete pods, but nothing else. So when you give that RBAC permission to the user, like basically what happens is that they can just do that specific access control and nothing else. And like by default, RBAC plugin is enabled in the cluster, and it's just that the cluster admin should create policies, or say they want a new policy or a custom policy. They need to create a new cluster role or a normal role and assign it to a specific user. And the last one being plugins. So Kubernetes uses a lot of plugins in terms of like Calico, a lot of networking plugins and so on. And recently, I think this year or last year, there was a talk on Black Hat about how people abused plugins. How I think Palo Alto abused plugins to container escape and get cluster admin just because of the plugins being had bad RBAC. I've also included the link for that specific talk in the references. Yeah, so this specific Docker file, it's just creating a Flask server, doing a apt update, installing the app server, and running the app server. So, like when can someone try to spot what is the vulnerability in this Docker file? No guesses? Alright, so yeah, basically when we run this Docker file, the Docker container which gets created is going to run as root, because we didn't use the user directive, like say how we used from, run, or copy, cmd and so on. There is a directive called user, and it really matters where you run the user directive. Say for example, you run the Python server, then you run the user directive, the Python server is still going to run as root. But say you put the user directive somewhere up on top, all the commands which run after the user directive is going to run with that specific user, as long as that user exists on the file system. Yeah, and about initial access to Kubernetes cluster, like there are few ways. One of them being like the keys getting exposed on GitHub or any external servers or configuration files and so on. You could get the key to either join the cluster as a worker node, or if you get access to the kubeconfig file, you can directly talk to the cluster with the permissions of that specific kubeconfig. And apart from information being leaked on GitHub or other platforms, another way of exploiting cluster is, say you get an RCE on a web application, and that web application is running in a Docker container inside a Kubernetes, and say you have root. Like what we could do is like try to escape out of the host. Just even though we are inside the container, if there is a bad misconfiguration, you could try to go out of the container runtime, escape to the host. That's just using RCE. Or say a web application, we have a file inclusion. You can read files from the server, right? So the admin credentials which get created in etc kubernetes admin.conf, it basically has the root has root privileges. So if the web application is not running as root, you wouldn't be able to hit the file, right? But like say for example, this specific screenshot, we have created a new user called Colby, and we have assigned the client certificate, the client key of this specific user. What Kubernetes is going to do is like go to these specific files, automatically take the certificates and create the configuration. And when you run kubectl get pods, this file automatically get translated to the certificates, client keys, and Kubernetes handles it. So here in this scenario, like what could happen is, say the web application is not running as root, and the application server, the server process basically has access to these files, these folders. What you could do is you can pull out these files separately, create the whole cluster config by yourself. It's just you need to add the server name, the certificate authority, the certificate, the key, all of them, base64 encoded, put them in the configuration and run kubectl. You should be able to hit the cluster just with the file inclusion. All right. So, yeah. So the next thing we are going to see is admission controllers. So while I was reading about admission controllers, I saw this really good analogy about admission controllers. It's like say you go to an airport, say you're going to board a flight, right? Like we're going to have the passport or the identification which you have, the flight ticket data and so on. Consider that as the Kubernetes API authentication and authorization. After that, we're still going to go past the security, right? We're going to go past the security and say we have something which we shouldn't have. It's going to get rejected, right? That's basically admission controllers. So admission controllers are a type of resource, I would say. Admission controllers as a resources, just like pods, deployments, or config maps, secrets, and so on. It's a type of resource in Kubernetes. It basically keeps the whole cluster from objects which you don't really want to be entering. Like by objects, I mean any resource. It can be a pod, it can be a deployment, it can be a secret or whatever. You can just create an admission controller saying that any object which comes in, if it does not conform to the policy I don't want the object to persist at all. So what happens is, what would happen then is like the etc daemon where all the resources or whatever data gets stored, it wouldn't even reach the etc daemon. The API call is going to get dropped just because the admission controller rejected it, even before writing it to the cluster. And so how do we go about creating admission controllers is you can, so the first step is you need to create a web application which basically runs a web server, right? Which runs a web server and waits for connections from Kubernetes. And the second step is you register admission controller in the Kubernetes. And after you register, like you write the policy inside the web application. After you register, whenever a new pod gets created, that's going to go to the admission controller at the last and see if that resource should be allowed or not. And controllers are basically two types, validating and mutating. Validating is just like it validates the whole condition. Like say, I don't want images anywhere apart from docker.io. You can like write a rule for that. And if someone in the cluster tries to pull images from, say, a different registry, like an internal registry or something else, the admission controller is going to say you can't do that because you can only pull images from docker.io or whatsoever. But mutating on the other side, it validates and also it has an option to patch the whole RPC request. So basically what could happen is like say a request goes to the mutating controller. What it could do is like say it sees that there is no label. Say there is a label called development, which is required for all the pods. And one of the pods, when you create the pod, the label is missing, right? What you could do is using mutating controllers, you can patch the whole request and you can basically patch it to include a field which you want. And that's the primary difference between mutating and validating controllers. And by default, like there are quite a lot of plugins or a lot of controllers which are enabled in Kubernetes. And we would have like seen some of them, one being pod security policy, which Kubernetes really recommends us to use. And pod security policy is again a type of admission controller. And there are like multiple other controllers as well. And so basically this is like say, when we run kubectl command to create a pod, right? We do kubectl apply whatever YAML or kubectl create a pod. It goes to the API handler and API handler is basically the Kubernetes API server. It goes to the API server, handles the authentication, checks RBAC, checks for authorization. Then it sees if there is any mutating admission controller registered. If it doesn't, it's like it checks the object whole object schema. Then it goes to it goes and checks if there is an admission controller, and say there is an admission controller, and it just like checks the logic, like it sees what should I do on this resource, should I allow it or should I not allow it? And after all of this, it gets written to the etc database, etc daemon. So basically after all these steps, if any of the steps fail, it's not going to be written, like that specific resource, it's not going to be written on the cluster at all. Yeah, so now that we know that we have to create a web application which handles request from a Kubernetes server, or which waits for request from a Kubernetes server, how do we go about writing, or say you want to write a new controller, like how do we know that what's the structure, what's the request structure, like what is Kubernetes going to send us and what's the response is going to be like? And since it is Kubernetes is open source, like we can just see so that specific file which is there on GitHub. It has multiple classes: admission review, admission request, admission response, and so on. Just look upon the structure or class for these specific names, and say you read the admission request. We are going to know that what's the structure for the admission request and what it expects. Say UID is a mandatory field when you handle controllers. So you know that, okay, I need to create a UID and so on. And yeah, this is basically the previous one which we saw was admission request, and this is the structure for admission response. And this is basically a YAML file which we need to create to create a webhook in the Kubernetes cluster. And this is just a basic YAML file which you can use to register a controller. Yeah. So while I was just seeing like how do I, so basically I wanted to enable admission controllers on the cluster I was running, and like one of the ways, like quick hacky ways I thought of was just like see where the Kube API server is running, from which exact file it's taking the configuration, probably change the configuration and see if it works. And so basically this specific file, etc Kubernetes manifest kubeAPI server.yaml, contains like the configuration of how the kubeAPI server is going to run. And here, like in enable admission plugins, I just added a few other plugins and saved the file. And like, yeah, so basically this worked because it's a static pod. We'll just see what static pod like in a bit. And these four are static pods like etc daemon, kubeAPI server, controller, and scheduler are like static pods. Static pods are just nothing but it's like a pod which is handled by the kubelet and not the API server. So when it crashes, right, when the kubeAPI server crashes, goes down, the API server doesn't need to tell, oh, it went down, bring it up. The kubelet, it like knows by itself that something is wrong, because since all these four components being like core of Kubernetes, if one of them crash, the whole cluster is not going to work, or some shit's going to go wrong. So that's the use of static pods. So you create a YAML file, put it in this manifest, and say you want the Nginx server here, just put on the manifest here. What is going to happen is, whenever that Nginx server crashes, without waiting for the API server to tell, okay, it crashed, kubelet automatically brings it up. And kubelet, we saw that kubelet is going to be running on all the nodes, the master node, the worker node, and so on. So yeah, after I had changed the manifest file from the previous screenshot, I was like, I wasn't sure that it wasn't going to work. But then after a few seconds, I tried running kubectl to get pods. It didn't work. Like I was not able to reach the cluster. Like after I would say 10 or 15 minutes, I was still trying to figure out what went wrong, or if the way I did, like obviously it wasn't the right way of doing it, but I just wanted to see like why it didn't work. But like luckily after 5-10 minutes, I saw that the pods which died automatically got created. Then like I read just like why did it happen, and static pods being the reason why it happened. So here we can see like these three components, the first three components, right? QBAPA server, controller and scheduler, it crashed, but it automatically restarted, even though I didn't restart it, or even though I didn't write a rule or tell Kubernetes to restart it. The kubelet automatically figures out that, yeah, something is wrong. I'm going to restart whatever. And since all these processes were restarting, that's why kubectl get pods didn't work in the first place. Like things were getting restarted, and after 10 minutes, like I was able to reach the cluster, and whatever had changed in the manifest file got reflected. Like so, the admission controller got enabled. Yeah. So the right way of doing it is create a configuration file. Say you want for the cluster, you want for the kubelet, or you want for a scheduler and so on. Just find out what's the specific kind to be used. So here, kubelet configuration or cluster configuration are like the ones which you use to run configurations on the kubelet or the cluster. And there are other types as well, right? So just create the YAML file, tell extra arguments. I need all these arguments. I want this plugin to run, this plugin to run. I don't want this to run. I want to run on this IP, and just save the YAML file. It will automatically create the kubeAPA server just like how you want it. Yeah. So on writing controllers, so the first step which we saw earlier, right, was writing a web application which handles the logic of controllers. It can be anything. It can be in any language, as long as it can run as a pod, which gets translated to a service in Kubernetes. You can write it in pretty much any language. And the first step being, like, we need to write the logic for the web, write the webhook logic basically, and create a Docker image, which needs to be run as a container in the Kubernetes environment, and do a Docker build. So the first screenshot, we're just doing a Docker build, and it basically builds the Docker container image like how you want it, and you tag the image to somewhere where you can push, like a registry where you can push, and you just push the image to, like I just use docker.io to push my images. You push the images to docker.io, and when you want to pull the image from, when you basically want to pull the webhook, the controller, admission controller image, it is going to go to docker.io, see that if this is there, and just pull the image into the cluster. So that's the first step of writing the web application. And the second one is creating a webhook configuration file. The kind we're seeing here is like validating webhook configuration. So we just declare that, okay, this YAML is a validating webhook configuration, and we say that I need the service name to be validate.default.service, and I say I want to run this specific webhook on all create operations, or you can basically run it on other operations as well, like say delete pods. When delete pods get called, the specific verb, you can include the verb here saying that delete, and when delete gets triggered, any delete resource gets triggered, it goes to the controller and checks for the logic, and you put the certificate in the last step. And so the first step, the main screenshot, we're just creating a webhook configuration, right? We're just registering a webhook. But on this screenshot, you can put both of them in the same file. But yeah, like I have created two different files. On the second YAML file, what it does is it just creates a service. And service, as we saw earlier, service is just an internal IP which gets created, maps to a domain name. So Kubernetes knows where it needs to send the request to. So you create a service with the same names which you use to the webhooks, and in the last step, we're going to deploy the controller which we wrote and pushed to Docker. We're going to deploy that into the cluster. You write deployment configuration and you just say that I need the image from this specific Docker repository, and on this specific port 443, I want the deployment to be running. So in the backend, it's gonna create a pod, which in turn creates a container with that specific image of the admission control logics. Yeah, after this, after you create create all the YAML files which we want, we just do kubectl apply and the YAML file, and if everything goes smooth, you just see if the service got created, if the webhook got created, and so on. And like here, we can see that whatever pod which we wanted to run, like the last 5-6 lines, we can see that it pulled the image from wherever repository I gave. And also, since we wanted a webhook to be running, which was there in the webhook configuration, it automatically ran a webhook, created a webhook, and also started the webhook on that specific pod or that specific service you wanted. Yeah, this is one of the, so basically this code snippet, like what he's trying to do here is, so he the author just creates the web application. It waits for a validate API call, and the validate API call should be sent as post because Kubernetes is going to post some request, right? So when the webhook is deployed, it is going to wait for the request, and like we know from the structure of the Kubernetes which we saw earlier, we sort of know what to expect, what fields to expect, like what parameters to expect, and so on. And we just say that okay, if the request which the webhook gets has a label, or if it doesn't have a label, say if it has a label, allow the container to run, or allow the resource to run basically, and if it doesn't have a label, reject the container. So that's what's happening here. And this is one configuration which I wrote to block images from arbitrary domains. So very similar to the previous example which we saw. Just that previous example on line 22, we can see that whatever we initialized, we're just trying to get the request.object.metadata.labels, right? So that prints out the label of resource which gets created in the cluster. But here on the next screenshot, it's trying to hit a different structure, which is request object spec containers. So this object is responsible for all the container related shit that goes on in Kubernetes, like the container name, the version, and so on. So basically when we hook into this specific structure, we are going to know that what's the container name, what's the container configuration, and so on. And from there, we know like what's the URL it uses to pull Docker images from. And say if it's not the URL which we want, we can automatically we can automatically stop it from getting created. And that's basically handles the request, and the response is basically again a structure which is standard for Kubernetes resource admission controllers. And you just say that okay, this is the API version, this is the kind, this is the response. You say if that specific resource is allowed to enter or not allowed to enter, and say you want to give a message, like say a message saying that okay, you can't run it because you're not pulling it from docker.io, whatever. That message you can configure in the messages, and the webhook, when it gets triggered, it's going to handle all the logic and tell you like, okay, you can't create a resource, you can't delete a resource, and so on. Yeah, so this is just a sort of me running the previous shown admission logic on the cluster. Basically, I had just whitelisted like whitelisted this specific Amazon AWS URL. Like it could be any URL, right? And the first screenshot, we can see that when it tries to pull an image from docker.io, Nginx, it's the same, like Nginx server, it rejected the request because the image is not from a trusted repository like how we described it in the webhook logic. And the next step, it allowed it because the image is from this specific URL. And since we allowed it, even though it's the same Nginx server, it didn't get it from Docker, but it just got from this the second URL. Yeah, and the last few steps, how did I create a cluster for testing? Like I was just using Vagrant, which is a tool written on top of the VirtualBox APIs or the VM APIs, which you can leverage to create virtual boxes. Say you want to run master node on a specific virtual box, and say you want to run 2 worker nodes on 2 different virtual boxes. We can't go ahead and create virtual box one by one, update it one by one, right? That we can just use Vagrant to automate the whole process of creating virtual machines. And after you create virtual machines, basically you can configure pretty much everything you want. Like what's the CPU, what's the IP you want to use, what's the network range you want to use. And the best part is, after we run Vagrant, say you create a Ubuntu server with Vagrant, right? It's not going to have Kubernetes by default, or Kubernetes is not going to run there by default. So that's where we leverage provision scripts. So provision scripts are basically shell scripts. Which you can write and connect to the Vagrant file which we saw in the previous step, and say that, okay, whenever you create a master node, run the shell script for me. And inside the shell script, you can say that basically installed all the necessary resources which you need for Kubernetes, like container runtime, Kubernetes service, and so on. And in the previous step, on line 34, 42, we can just, on 25, we can just see there is a provision script which is getting called, which basically have the path. Also, you can pass environmental variables from the Vagrant file to the shell script, basically. And it runs the whole, it basically runs the shell script. And the best part is, the shell script fails anywhere, it just tells you it failed there, so that we know what went wrong or where it went wrong. And this is, how you just start a cluster. Just you do a ADM init, and you create a token, which you can use for the other worker nodes to connect to the cluster. And this is just the log of the cluster being run. So the top screenshot, master node is being run, and the bottom screenshot, worker node is being run. So basically the virtual box got created, the shell script got run, and Kubernetes, it's running on that specific VM, which can be, so using the kube, which can be reached from the host operating system, basically. So for testing, you can create 3 VMs, assign the private network IP, and you just access it from the host. And this is just a screenshot of just an nmap scan from a host machine to the Kubernetes cluster. So the first one is a master node, the rest 2 are worker nodes. Basically, since you can reach it from a host machine, it's easier to test the whole cluster from your host operating system. And also, if you want to try it out, I've just uploaded all the Vagrant files, the shell scripts on my GitHub today. You can just have a look if you want to have. Yeah, that's pretty much it. Any questions? Anything that needs clarity? Anything at all?
Yeah, if you change your admission controller, is there a way of a nice, tidy, easy way of making sure the things that are already running would have got from that admission controller, or do you sort of have to?
No, we need to deregister the admission controller, because when we register the admission controller, it would have already created a service which is assigned an IP and a port and the image which we want, and say you update the image, you need to deregister the webhook and pull the image basically again, deregister the webhook, register the webhook, so that whatever changes we made gets reflected.
But once you've done that, can you make sure that the other applications that are already running in the cluster, they would have passed it?
No.
Okay.
You can't know, because like here, like where. Yeah, so in the operations, like since we said create, only when create gets triggered, the controller gets called, or list gets triggered, delete gets triggered, the controller gets called. I don't think there is a way to reload all the web applications unless and until you restart the pod itself, restart the container itself.
Cool, thanks.
Cheers. Anything else? Please.
Yeah. When you create an admission control is a very basic HTTP web service, and you build it as a Docker container. You said you push it to Docker Hub.
Yeah.
Is it possible to tell your Kubernetes cluster to pull from a different repository?
Yeah. So basically,
is that in the Kubernetes config?
No, it's in the Docker config. So basically, when we pull Docker images, what you could do is like when I push, right, when I did a Docker push, I had to do a Docker login to Docker Hub, say, and pushed it to the registry. Say your company is using a private registry, you can log into that specific Docker registry using Docker login, and the username password is going to get stored in locally, and whenever you want to pull from that specific private company registry, it pulls from there. Anything else, guys? Cheers. Thank you.